Hi class, we're going to continue our study in chapter 1. And what we're going to talk about now is section 1.7. This is coordinate geometry. Continuation of this, we're going to talk about midpoint and distance formulas. We have two objectives in this section. We want to find the midpoint of a segment. That's going to be a really simple formula. And then the last thing we're going to do is we're going to find the distance between 2 points on the coordinate plane. This is also going to be a very simple formula to follow. All right, and I'll walk you through them both with examples, things like that. All right, so midpoint. So recall from a previous section that a midpoint of a segment is a point that divides or bisects a segment into two congruent segments. So what that means is if you have a long segment, you find the midpoint, right? The segments to the right and to the left of that midpoint on that segment are going to be equal lengths. That's what that means. All right, so I got two midpoint formulas first. All right, so the first one is on a number line. All right, so just a single number line. The coordinate of the midpoint is the average or mean of the coordinates on the two endpoints. So if you're given segment AB on a number line, the coordinate of the midpoint M, right? So here's point A, here's point B. We'll say that point A has value lowercase a, point B has value lowercase b. To find this midpoint M, you're just going to take A plus B divided by 2. That's it. That's all you have to do. On the coordinate plane, it's a little bit more difficult. So the coordinates of the midpoint are the average of the x coordinates and the average of the y coordinates of the endpoints. So here, if you have line segment AB, right, where A, this point right here, is value x1, y1, and B here has values x2, y2. The midpoint of this segment, well, remember, it's a point, so it has an x and y value. First thing you're going to do is you're going to add the two x values, x1 plus x2, and then you're going to divide that by 2. And then you're going to do the same thing for the y values. You're going to take y1 plus y2 and divide that by 2. So remember, when you have a segment in the coordinate plane where you have that xy axis there, right, your midpoint is going to be an x value and a y value. Remember that. All right, so let's do two examples here. Let's talk about finding the midpoint on a number line. So I have this diagram here. Right? So use this and find the coordinate of the midpoint, we'll call that point N, of the segment PQ. Well, the first thing you should do, you should see is the coordinate of P here is -3, and the coordinate of Q is 10. So using that formula, if we let A equal -3 and B equal 10, or simply find the average of -3 and 10. So the midpoint, you're going to take the two values and divide by 2. You're going to sum them and divide by 2. So -3 plus 10 divided by 2 gets you 7 divided by 2, gets you 3.5. So the midpoint here, here's 2, here's 4. That means this is 3. The midpoint right here is going to be 3.5. All right, let's find the midpoint of the line segment PQ, and that is joined by the endpoints P, which is -3, 3, and Q, which is 1, 0. All right, so we're going to use the midpoint formula to find the midpoint, obviously. So it makes no difference which point we call x1 and which point we call x2. However, generally, what I will always do is call the first point P here x1, y1, and the second point here be x2, y2. So x1 is -3, y1 is 3, x2 is 1, and y2 is 0. All right, so the x coordinate of M, I'm going to take the two x values, sum them and divide by 2. So -3 plus 1 divided by 2 is equal to -2 divided by 2, which is equal to -1. All right, that's just the x coordinate. Now remember, the midpoint on when you have a line segment and a coordinate plane, you need 2 points. So I found the x coordinate. What I need to do now is find the y coordinate. So the same thing, the y coordinate of M, I'm going to take y1 plus y2, divide that by 2. So 3 plus 0, because here's y1, here's y2. 3 plus 0 is 3. 3 divided by 2 gets me 1.5. So the midpoint of segment PQ is -1, 1, 5. So remember, you needed both points here, right? The -1, I'm going to go back, comes from here for the x value. And the 1.5 here comes from the y value. All right, let me throw a harder problem at us. So I have this line segment, we'll call it CD. All right, and I tell you that the midpoint, I'm giving you the midpoint, not the two endpoints. The midpoint is negative 2, 1. And one endpoint, right, I'll give you the C value, is negative 5, 7. So here, negative 5 up to 7 is one endpoint. This is the midpoint. So I want to know the coordinate of point D somewhere down here. What is it? So how the heck am I going to figure this out? All right. So what I'm going to do, I'm going to start by writing what I know. I'm going to let M, right, the midpoint, be negative 2, 1, be equal to x comma y. So this is, I'm going to go back from our formula here. Forgive me for going back. All right. We're going to say that this is equal to x, and this is equal to y. That's what we're just going to call it, okay? And we're going to let the coordinates for C be negative 5, 7. That's going to be my x1 and y1. And I'm going to let the coordinate of D, the unknown I'm looking for, is going to be that x2, y2. That's the second x value and second y value. I don't know what it is. That's what I'm looking for. All right, so using that right here, here's what I see. My midpoint, so my x value of my midpoint is equal to the x1 value, negative 5, plus x2, I don't know what that is, divided by 2. And my midpoint of my y value, 1, is going to be equal to 7 plus y2, that unknown other y value, divided by 2. So I'm actually going to have to solve two different equations, one for x, one for y. So we'll start with the x. Well, I know the x value of the midpoint is negative 2. Well, that's going to be equal to this. So to solve this, first thing I have to do is cross multiply. So negative 2 times 2 gives me 4, is equal to negative 5 plus x2. So then I'm going to add 5 to each side. That tells me that my D point over here, the other endpoint, the x value is equal to 1. I need to do the same thing for y. So now y1 is equal to 7 plus y2 divided by 2. Again, cross multiply. So 2 is equal to 7 plus y2. Subtract 7 over, and you get negative 5. So what that tells me, the coordinates of the other endpoint D are 1 comma negative 5. All right, let's end talking about the distance formula. So the distance between 2 points. So we'll have our first point here, A. It's going to have x1 and y1 as its coordinate. And point B up here is going to have x2 and y2 is equal to this distance, so the length of this segment here. This is important. I'm going to take the difference of my x values, and I'm always going to do it in this order. x2, the larger one, minus the smaller one. So x2 minus x1, then I'm going to square it. Then I'm going to do the same thing with the y values. I'm always going to do y2 minus y1 and then square it. So I'm going to take the differences of x and y squared. I'm going to sum them. When I get that sum, what I'm going to do next is I'm going to take the square root of it. So this distance formula is based on what we call the Pythagorean theorem. This is what we're going to study later in this book. All right. So when we use this distance formula, what we're really finding is the length of the hypotenuse of a right triangle. So if I were to draw dotted lines down from B and over from A, you'll see they intersect to form a right triangle. The hypotenuse of a right triangle here, right, is always the hypotenuse is always the length of the largest side. That's really what we're finding. All right, so let's do an example. So find the distance between point A, which is 2 comma negative 5, and point B, which is 1 comma negative 4. All right, so let's give an exact distance and then a 1 decimal place approximation. All right, so again, I'm going to start by letting the first point be my x1, y1, and then my x2, y2 is going to be my second. So I'm simply going to plug it into this distance formula. Now, please forgive this. There's a typo that I'm going to explain on the next slide. All right, so just notice it. So distance, I'm going to take x2, which is 1 minus 2. I'm going to square it here. And here's the typo. y2 is 4, but it's really negative 4, so there's supposed to be a little negative in there. So forgive that typo. So it should be negative 4 minus, now be careful here, minus 5. So minus, minus. When you see double negatives, that becomes positive. So 1 minus 2, that's going to be negative 1. And don't forget, this is negative 4 not minus minus, but plus. So negative 4 plus 5 gets me 1. So I have negative 1 squared and 1 squared. When I square each of those, I get 1. So the distance here between these points is just equal to the square root of 2. And if you plug that into your calculator, you'll see that it's equal to approximately. So that's what this squiggly line means. It means instead of equals, it means it's approximately equal to 1.4.